This lesson is on the basics of sine and cosine graphs, and we are going to start with the basic sine graph. It'll be y equals sine x or y equals sine theta, y equals sine phi, some kind of variable there. But we're not adding anything to it. We're just going to talk about knowing the basic shape. First of all, the y-axis is going to be easy. If you look at your unit circle, the highest y value you have is 1, and the lowest y value you have is -1. And also, the x-axis isn't that bad either. We're just going to do one period, which I'll talk about what a period is in a little bit, but one trip around our unit circle, basically plotting points. So when we go around the circle one time, we go from 0 to 2 pi. So I'm going to mark the end 2 pi, but I'm also going to label pi, which is the halfway point, and then the two quadrant markers, the pi over 2 and 3 pi over 2, because important things happen at those places on this graph. And so that's how I want you to start out. I want to see those labels on your graphs. Now, the shape of the sine graph, if you plot these values, think about it from your unit circle. The sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is -1. And the sine of 2 pi is 0. And what happens is, if you were to do all of the points in between them, you would get the points that fill in. But you can get the basic shape from knowing those values. And this is going to be a smooth curve, just kind of like a wave. And it's going to be a little bit hard for me to draw, but I'm going to give it a shot. Just know that it's smooth, and if you want to see a nice smooth version, you can look in your book. And again, I expect you to be able to do this as well. And so that's the best that I can do at this point. Okay, now, like I said, this keeps going, because if you go around the unit circle backwards, that would be putting the graph over here. And if you go around more than once, you go here. So this thing actually continues on in both directions forever, doing this nice little wave. For that reason, the domain would be from -infinity to +infinity, and you can write it like this, or you can write it with bracket notation, or you could write that as all real numbers. All three of those are acceptable ways. You don't have to put all three, just pick the one that you like and go with it, but understand all three. Your range, the lowest y value it goes to is -1, and the highest y value it goes to is 1. Even though it does keep going left and right forever, it is bouncing between those two y values. So your range would be from -1 to 1, and including those, so you'd have the equals marks. Or if you're using bracket notation, from -1 to 1 with the square brackets to say that it's included. Now, the zeros, zeros are where this graph's crossing the x-axis. So that's at 0, at pi, at 2 pi. Basically, anytime you have a sign of 0, which is on the x-axis when you're looking at your unit circle. And so there's so many to list because it goes in both directions. We write a little formula because it's impossible to, again, write all of them. But if you'll notice, okay, think about it: 0, pi, 2 pi, 3 pi, 4 pi. It's all a number times pi. Even if you go the other direction, -pi, -2 pi, -3 pi. So our formula is n times pi, or k times pi, some letter times pi, where n is an integer. And another way to write that you might see at some point is n and then this little e and then a z with a double line. That means integers. Just like this double r means real numbers, this double z means integers. This is like the short version of writing it out in words. Mathematicians like to take their shortcuts. Alright, let's move on to cosine graph. Cosine graph is really just a shift of the sine graph because, on your unit circle we're using those same x and y's values. Cosine gets those same values as sine just at different times. So again, when you're thinking about the cosines from your unit circle, the highest one that you ever get is a positive 1, and the lowest one that you ever get is a negative 1. And again, we are going to start with just going around the unit circle one time. So to 2 pi, I'm going to label my axes. Pi would be the middle point, and then I have pi over 2 and 3 pi over 2. And let's think about what our values from the unit circle are. The cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is negative 1. The cosine of 3 pi over 2 is 0. And the cosine of 2 pi is 1. And so again, this is going to be a smooth wave graph, and it's really just like the sine graph except shifted over. And it's like a hill and then a valley and then a hill. And if you were to keep going, it would just make that hill connect with the next one, and it will be a nice smooth wave. And again, if you go around more than once, it's going to the right. If you go around the unit circle backwards, we're going to the left. So this thing does continue forever, making our domain all real numbers. Our range, again, the lowest that you have is negative 1. The highest that you have is a positive 1. So I'm going to write that in bracket notation because I like short and sweet. And then let's think about our zeros in this case, because that's what's coming up next. We're crossing at pi over 2 and 3 pi over 2. And so the next one would be at 5 pi over 2 and then 7 pi over 2. So we need to write a little formula for those. So obviously it's multiples of pi over 2, so I'm going to say n pi over 2, where n is an odd integer, because we had the 1, the 3, the 5, the 7. And that will work. Another way to write it is, say, pi over 2 plus n pi. That will land us in the same places. So if I start at pi over 2 and I add pi amount to that, which is basically half of a circle, you end up in the same place. But in that case, the n multiples of pi would just be a regular integer. So where n is an integer. Either one of those, you don't have to write both, you just have to understand how to make one of those to be able to answer your questions. Okay, vocabulary. These are things that we're going to be using to talk about these graphs. First is period, and that's what I alluded to a minute ago. It's how long it takes to make one cycle of the graph. So for sine, you want to see a full hill and a full valley. That takes 2 pi. For cosine, you see part of a hill, valley, and then part of a hill, and that takes 2 pi on your x-axis. We will be working with changing that period in a lesson to come, but not for today. We're just going to keep everything at that. So one cycle of the graph. Know what you're looking for, and for sine and cosine, that's 2 pi. The midline runs horizontally through the middle, and so far the two we've shown, it's just been y equals 0 because we haven't vertically shifted anything. But if you shift it up, the middle of the graph is obviously going to be up somewhere, or if you shift down, it'll be down. Amplitude is kind of like looking at the vertical stretch of what's going on. It's the distance from the midline, wherever that is, to the max or the min. Okay, so it's a distance. Now, how are you going to know when you have some changes? Here I have in purple what it's going to look like if you have a amplitude change. And they're going to put an A, well, I have an A, they're going to put a number in front of your sine or in front of your cosine. And the absolute value of that number is that amplitude that we just talked about, that distance. If it's negative, that doesn't mean the graph is shifted down. That means it's a vertical flip. So again, when you look at that number, you're looking at the stretch from the midline, and if it's negative, it's flipped vertically. So for a sine graph, that would mean instead of going hill and then valley, you would do valley and then hill. So we're going to sketch some of these. Okay, I'm going to start with 3 sine theta. And so this 3 means that you have an amplitude of 3. Instead of going to 1, it's going to go up to 3. So I want to make sure I label my x-axis and my y. Well, my x-axis will stay the same. The y-axis is going to need a little bit more than we had before. It's also going to go down to -3 because it's just taking those sine values, those y values, and multiplying them by 3. So if you multiply 1 by 3, you get 3. If you multiply 1 by -1 by 3, you get -3. And the x-axis stays the same. Like I said, for today, we're not changing that. So I'm labeling the same stuff that I did before directly from my unit circle. And for the sine graph, I'm going to start at 0. The pi over 2 is now going to be up at 3. Then I'm going to be on 0 at pi. The 3 pi over 2 is going to be down at -3. And we'll be back at 0 at 2 pi. And then I'm just going to make my hill. Oh, it's moving. And my valley. So, a little bit of an issue there. But you get the point. Now we are going to sketch our second example. This has a couple of changes. The negative, again, notice that's negative. That means you have a vertical flip. So I'm going to flip what was down up, what was up down. The 1/2 is now my amplitude. Notice I don't include the negative with that, again, because your amplitude is the absolute value of this number. It's just a distance, and we don't have negative distances. I'm going to go ahead and label my x-axis because nothing is changing for today. And then my y-axis now, we used to go up to 1 and down to -1. But when I multiply those values by 1/2, I come to 1/2 and -1/2. So it's going to vertically shrink my graph. Now, the thing about it is, you have to remember to flip your graph. You can get in the habit of going really fast and think, okay, amplitude of 1/2, and do your cosine graph and totally forget to flip it. So that's why I like to write it down, remind myself to flip. The cosine normally starts at 1, but with an amplitude of 1/2, it would be 1/2. However, since we're flipped, we're going to do -1/2. You'll still be on 0 at pi over 2. At pi, normally that's at -1. It would be at -1/2, except we're flipping, so it'll be at +1/2. And I think you can see the shape once you start plotting the others. It's your cosine graph. It's been vertically shrunk and flipped. Okay, the other thing that we're going to add today besides amplitude is a vertical shift, and this is just going to move your midline up or down. And if you remember shifting graphs from your previous math classes, that happens when you add or subtract a number on the end, and it looks exactly the same with your trig graphs. So if we have a plus something on the end or a minus something, that graph will move up or down. So a plus is going to move up, a minus is going to move down. And let's go to example 3. So with example 3, we have the regular cosine graph, and we're moving up 3 because of that +3. So I'm still going to label my x-axis with no changes. And I'm going to start with my y-axis. I know I've got to go up 3, but if my middle moves up 3, and I normally go up to 1, that's going to be now at 4. So I need to make sure I get to 4 in my labeling. And you can put some negatives, but we're probably not going to end up down there. Let's think about our cosine graph again. And I like to, when the midline moves, put a little dotted line to remind me where that is, that the middle is now there. But your cosine graph goes starts one above your midline and goes to one below your midline. So everything should fit between 4 and -2 when you graph it. So think about, again, your hill, valley, hill. We're going to start on 4. At pi over 2, we're going to go through the midline, because normally it would be on 0. At pi, we're going to be at our lowest point, which would be -2. At 3 pi over 2, we're going to be back on the midline, and at 2 pi, we're going to be back up at 4. So then I sketch it all together, and you can see it's just your cosine graph moved up 3. Okay, nothing stretched or anything, just moved up. Okay, for our last example, I wanted to do a combination of both things. So this 2 means that I have an amplitude of 2. We're doing a sine graph, so a full hill and a full valley. And then this -5 means I moved down 5. So again, start with your x-axis because that's the easiest thing to do at the moment. 2 pi, pi, half of that, and then 3 pi over 2. Again, think about your sine graph. Normally we go up to 1 and down to -1. But if I move my midline down 5 and I have an amplitude of 2, I'm going to go 2 below that. So I'm going to go all the way down to -7 with this graph. And so I need to make sure I have enough labels on my y-axis to hit that number. Okay, and then I'm going to put in a new midline at -5 to remind myself, okay, that's the middle. Okay, but again, with an amplitude of 2, wherever that midline is, that means I'm going to go 2 above, so -3 is the highest it'll go, and 2 below, so -7 is the lowest it'll go. It's going to fit between these values. Again, this is the sine graph, so we have a hill and then a valley. We're going to start on the midline. We're going to go to the top of the hill at pi over 2, which will be at a y value of -3. At pi, we should be going back through the midline. At 3 pi over 2, we should be 2 below. And at 2 pi, we are back on the midline. So then I connect it and make my sine graph shape. And that's what the graph's going to look like with both of those changes at the same time. And, you know, they could throw a negative in there and make you flip it, be a valley and then a hill. Just any of those different changes that we've talked about today, expect. That concludes this lesson.